Hi Namkolo, welcome to this lesson video. So in this lesson video, I want us to look at free vectors. Now, you may recall that we've been talking about types of vectors. So we started by talking about equivectors. From equivectors, we talked about position vectors. From position vectors, we are here now. We want to talk about free vectors. So what are free vectors? Free vectors are vectors drawn to start at any point. Okay? They are different from position vectors. So position vectors, they somewhat have a fixed point that they start from, or that they'll be starting from. And in most cases, the origin. Okay? That's why they're even called the position vectors, because they have a fixed point where vectors are always starting from. Alright? Now here, under free vectors, vectors are able to start at any point. Now what is important to note is that the direction of a line segment is very important when we talk about free vectors, especially if you've been asked to write the vectors that have been shown on the grid and you write them in column form. Okay, so here we have an example. This example is saying identify the following vectors on the grid. So we have this grid right here, and on this grid we have these vectors that have been drawn. Okay, we have vector W, vector V, beg your pardon, this is vector V, then we have vector W, we have vector X, and we have vector Z, and also we have vector A. Now, we've been asked to identify these vectors. In other words, we want to write these vectors in column form. How do we write these vectors in column form? Okay, so let's start with vector V. So in order for us to write this vector in column form, we'll first move upward. Beg your pardon, we'll first move across. Okay, so we'll notice that the tail is here. This is the tail, and the head is right there, okay, for vector V. So what you do is that you first move across. So if you move across, you are counting basically the number of boxes that you have here. So you have 1, 2, 3. Then you check from here, you check the line going up if this line is meeting the head. And it does there, it is meeting the head. So you count 1, 2, 3. Okay, so you have moved 3 steps or 3 units across. How about upward or vertically up? How many units are you going to move? So here again you count the number of boxes. So here you simply count 1, 2, 3. Okay, so here you are counting from here, you count 1, 2, 3. Okay, so what you notice is that you have moved 3 units across, and here you have simply moved 1, 2, 3 units again up. Alright, so writing this vector V in column form, it will simply be, okay, the vector V, it will simply be equal to, so we have moved 3 units or 3 boxes, we've counted them across, so that will give us 3, and then we have moved 3 units up, so again we write 3 there. Okay, so like this, it means that we have written the vector V in column form. Okay, let's look at the next vector, which is the vector W. Okay, again, first we observe the direction of this vector. Okay, we can see the direction of the vector, it is in that direction. So first we move across or horizontal. Okay, so again this is the tail and that is the head here. Okay, so that is the head. So from the tail, let's move. We count the number of boxes. We have 1, 2, 3, 4. Okay, so we have 4 boxes here, or we are moving 1, 2, 3, 4. Okay, so we have moved 4 units across. Now notice the direction of the vector. Are we moving to the left hand side or to the right hand side? If you see the direction of this vector, we are going towards the left. Okay, so we have noted that, and here we have, just from here we have 1 to the head there, so simply have 1 box up. So how can we represent this vector? So this vector is simply going to be, so we are saying vector W is simply going to be, we moved 4 units to the left, so we are going to have -4, then only 1 unit, or we counted 1 box up, so here we have 1, so that will be the column vector W. Okay, next, X. Okay, so we have X. So if you look at the vector X here, the vector X, we are not going to move horizontally in any way, because this is just a vertical line. Okay, so this means that it is 0 units horizontal. Then how many units vertically? How many are we counting? So we are counting 1, 2, 3. Okay, starting from the tail here, remember your tail, your head. So here, if you want from here, you can count these lines here, 1, 2, 3. Okay, or you can count the number of boxes, 1, 2, 3. Okay, so it is 0 horizontal and 3 units up. So here what we are going to do is we say 0, then we have 3. Okay, 3 is positive because you can see that we are moving vertically up according to the direction. Okay, we come here, this is the vector Z. So the vector Z, look at the direction, we are going to the negative direction. So from the tail to the head, we count 1, 2, or you can count the number of boxes, 1, 2. Okay, so we have moved 2 units horizontally, and then from there we can count 1, 2, 3. So we have moved again 1, 2, 3 units downwards vertically. So here, writing this vector is simply going to be, so how did we count? 2. So we counted 2, and we are going to the left, so it's going to be negative. Okay, then here again we are going vertically downwards, so again it's going to be negative, so we have -3. Okay, lastly we have vector A. So vector A, okay, look at vector A. Vector A, we are only counting across horizontally, so here we have, from here we have 1, 2, or we can count 1, 2. Okay, and then we are not making any movement vertically, so this one is going to be 2, this one is going to be 2, 0. Okay, so in a nutshell, what I'm saying is that when writing a vector in column form, if you have directed line segment, if you are moving horizontally, if you are going to the right, it's supposed to be positive, going to the left, it's supposed to be negative. If you are moving vertically upward, positive, vertically downwards, negative. And so this is how you can write these position vectors. I'll see you in the next video.